Hi, in this video we'll be seeing about IPv4. So IPv4 Internet Protocol version 4 is the network layer protocol of the TCP/IP protocol suite. So we'll be seeing what is TCP/IP in the further videos. So in that we have the network layer protocol and the protocol used in that network layer is IPv4. Actually, IP is a connectionless, unreliable, best effort delivery protocol. So, network layer we saw in the previous video, its duty or the function is to deliver the data packet to the destination. So, here what it is connectionless, unreliable, best effort delivery. So, all the nodes are identified using IP address. So, packets are delivered from the source to the destination using the IP address. So IPv4 addresses are 32 bits. Okay. Then they are often represented in dotted symbol format as a sequence of four integers separated by a dot. We have seen this already in the first network ID and host ID and the 5 classes and all that. So network ID identifies the network, host ID identifies the network connection to the host rather than the actual host. So this is how an IPv4 datagram looks like, right? So packet format. So what is the packet format? The datagram consists of a header and followed by the number of bytes of data. So this is the header format of IPv4. So it has a header and then bytes of data. The IPv4 packets are use 20 bytes header. Okay, 20 bytes header, and it has got all these things we will be seeing one by one. For version field, right, it has got a version field which indicates the version of IP used to build the header. Presently we are using 4. Then header length. The length of the IP header is in 32 bits works. Okay. So this field allows IPv4 to use options if required, but as it is encoded as 4 bits field, IPv4 header cannot be longer than 64 bytes. Okay, so this header cannot be more than 64 bytes. Next is type of service. That also is there in the packet format. Indicates the quality of service requested for that IP datagram. Then protocol field indicates the transport layer protocol that must process the packets payload at the destination. How must be the packets processed at the destination. So network layer, its work is just to transfer the data from the source to the correct destination. So at the destination there will be some process. For that process this protocol field is used. So common values for this field are 6 for TCP, 17 for UDP. These are all the protocols. So next, length field. It indicates the total length of the entire IPv4 packet, header, payload, and also in bytes. So this implies that an IPv4 packet cannot be longer than 65535 bytes. So remember this, it cannot be longer. You saw the header, it cannot be more than 64 bytes. So similarly, length field cannot be more than 65535 bytes. So next is fragment offset. It is used to reassemble the full datagram. The value in this field contains a number of 64-bit segments, right? Header bytes are not counted here. So this 64-bit segments are contained in the earlier fragment. Okay. So the value in this field contains the number of 64 segments contained in the earlier fragment. So if this is the first, then this field value is 0, right? So if this is the first fragment, then it is 0. If this is the second fragment, then it will have a 1. So things like that. So what if you take nth frame, that's what here it is said. So this field contains number of 64-bit segments. How many 64-bit segments are there before this particular segment will be represented in this fragment offset. Then flags. This is containing 3 bits. Only 2 bits are currently defined. MF, that is more fragments, and DF, don't fragment. So these are the 2 bits that are currently defined. Then more fragments, MF. So a single bit in the flag used with the fragment offset for the fragmentation and reconstruction of packets. So to fragment and reconstruction of the packets, we are using this. The more fragment bit is set, it means that it is not the last fragment of the packet. So this means that we are going to receive more amount of packets, right? So when receiving a host sees the packet arrive if MF1 is 1. So it examines the fragment offset to see whether this fragment is to be placed in the reconstructed packet or not. Okay, so as and when you receive, you check this whether it is 1 or not. If it is 1, that means it still packets are yet to be received. So when a receiving host receives a frame with MF0 and a non-zero value in the fragment offset, it places that fragment as the last part of the reconstructed packet. Now you understood. So MF is 0, that means after n number of packets, if MF is 0, that means that particular packet is the last packet. Then don't fragment. This flag is again a single bit that indicates that the frame fragment is not allowed in this. Okay, if the don't fragment bit is set, then fragmentation of this packet is not permitted. If a router needs to fragment a packet to allow it to be passed downwards to the data link layer, but the DF bit is set to 1, then the router will discard this packet. So you should say whether this packet can be fragmented or not, right? Next, time to live, TTL. Again, this again is an important one. So it's an 8-bit binary value that indicates the remaining life of the packet. TTL value is decreased by at least 1 each time the packet is processed by the router. So it goes from one router to another -1, one router to -1. So that is how it happens. So TTL, that is how it is done. So when the value becomes 0, the router discards or drops the packet and it is removed from the network data flow. Then source address, field that contains the IPv4 address of the source host. Destination, it will contain the destination host. Then you have checksum. It protects only the header against the transmission errors. Checksum is for checking if there are any errors or if the data bits has been changed while transmitting the data. So it is contained in the header. If checksum does not match the contents, then that particular datagram is discarded. Then you have options. This one, it can encode the option required by the sending user. If the user are telling you any options, that will be put in this particular part. Next, padding. It's a variable one, used to ensure that the datagram header is a multiple of 32 bits, right? If you don't have that much amount of data, so you pad it with 0 so that it becomes 32 bits. Next is data variable. The data field must be an integer multiple of 8 bits. So maximum length of a datagram, it will be 65535 octets, right? Then this is how a IPv4 header will look like, right? Then TOS of terms of service for applications. For what and all, what will be using all this. Then again, a header format, how will a header look like? A single header, how it will look like. Identification, flag, fragmentation, time to live. This all we saw in the previous slides. This is again an IPv4 header, how it will look like for a high level protocol. Fragmentation, how it is done. Then field related to fragmentation, how the offset is set, how the bits are assigned and all that. Then this is again a diagram of how this datagram is fragmented into 3. Again this datagram is again fragmented into 2, and when it goes to the destination, it gets reconstructed.